All right. Solving equations and exponential, solving exponential equations and log equations. So some of this is going to be a little difficult today. I'm going to warn you on that one. Some of it's easy, like some of it will be super simple. But there's a lot of algebra involved and a lot of complex problems. So let's pause for a second and talk about these laws and these rules. So I want you to notice here that if I have the bases that are the same, then my exponents are automatically the same, meaning that I can cancel out my bases. The same thing happens with logs. If I have a log of something equal to the log of something else, I can cancel my logs out. Now, if you have pluses or minuses or anything like that in there, the rule will not work. You must get them down to single exponentials or logs, which is why we learned all those log rules, so that we can put them all into simple logs, so that we can cancel them out so we can solve. All right? So, moving on to the equations. Maybe? Okay, maybe I need, oh, there we go. All right, so you notice this equation here. I'm going to try to get it so I can use those rules. So I'm going to subtract 3 from both sides and end up with 3 to the x to the 27. Now, I'm going to change 27 to a 3 power, which means 3 to the x is 3 to the third. So then I can cancel out those 3's, and I get x equals 3. Okay? Now, this one is your practice problem. Okay, my recommendation is to think about that 8 as a 2. There's your solution. Okay, example 2. So now, this one you'll notice that the bases are not the same. So now we have to use a lot more complex problems. And honestly, this is probably the longest problem that I have on here. And in order to solve this, we need to get the x's out of the exponent. You cannot solve with x's in the exponent. So I'm going to take the log of both sides. And I can take log or I can take natural log. It does not matter which one I use. I use natural log because it's easier to write. Your calculator will do both. What ultimately it's going to come down to, it's going to be a calculator problem, but it's a lot of work to get there. I'm going to tell you right now, if I see problems like this and simply a single answer or even a one-line work, it's not acceptable. Okay, these are complex problems and they take a lot of work. So the first thing we're going to do is take the natural log of both sides. So I take the natural log of 4 to the 3x minus 1 and the natural log of 3 to the x minus 2. What that does is that tells me I can move the exponents outside, okay, because of my rule that says that I can do this. So I have 3x minus 1 times the natural log of 4 now equals x minus 2, maybe. There we go. Yeah, I messed up. Equals x minus 2 times the natural log of 3. Okay, now I want to get the x's alone, but I have to simplify first, so I need to distribute. I end up with 3x natural log 4 minus natural log 4 equals natural log x natural log 3 minus 2 natural log 3. Okay, now again, this is all algebra. Now I'm going to combine my x's, get my x's together, and get my terms without x's together. So I'm going to subtract x ln 3 from both sides, and I'm going to add ln 4 to both sides. I'm going to end up with 3x ln 4 minus x ln 3 equals ln 4 minus 2 ln 3. So I simply used algebra to move the things around. Okay, now this is where, oops, okay. I couldn't figure out where to go. When I was writing, I ran out of room. So anyway, move that over and see what we can do. So now I can factor out an x. This is really important that you know how to factor. I factor out an x, and I have 3 ln 4 minus ln 3 equals ln 4 minus 2 ln 3. And now I'm going to divide both sides by 3 ln 4 minus ln 3 so that I can have my x all alone. And at this point, I'm going to plug that all into a calculator. And I can do it all at once. I can do it in pieces. Keep in mind, if you do it in pieces, that your calculator's going to round different, so your answers might be slightly different, no matter how you do it, depending on where your calculator is. When I put in my calculator, I got negative 0.2538. All right, and that's going to be approximate. There's, you may have something similar. It's okay if it's off just a little bit. All right, so a lot of work just to solve for that x. Anytime you have x's in the exponent, there's work involved, unless they're easy bases. So now you're going to try one of these all by yourself. So you practice problem. Okay, so go ahead and solve that. Same way we just did it. Follow the exact same steps. Okay. Example 3. So now I have logs that I want to solve. So the first thing I'm going to do is I'm going to combine my logs together. So I will have log of 2 times x plus 1. This makes it very, very easy for me to be able to simplify this problem. So, because I can combine them. Now, since it's a log and a log, I can cancel them out. Simple. And I have 4x minus 1 equals 2x plus 2. I went ahead and distributed. And I'm going to subtract 2x from both sides and add 1 to both sides. Algebra. 2x equals 3. X equals 3 over 2. You can try one of these on your own in a minute, maybe. There we go. Okay. Combine your problems. Now, this is a little more complex. Hang on, let's go back. Here's your solution. One of these days I'll get this. There we go. Okay, I want to pause here. You'll notice that when you combine these are going to be multiplied together. You're going to end up with a quadratic. Okay. So your complexity here has absolutely nothing to do with the fact that you have natural logs. It has to do with the fact that you have quadratics. Likewise, you're going to need to move this out. This is much more complex than the problem I just did. So there's a solution. Try to get that off. Okay. And that's it. See you tomorrow.